over that process, a few new products have been developed. Get in the orchard industry, they've totally changed the way, the concept of watering orchards in the last 20 years. Since this class began, we didn't even know what a rotator was, for example, 20 years ago. Didn't exist. Well, today it might be the sprinkler of choice in orchards around the world. Just developed in the last few years. All of the different sprinkler packages that are on center pivots. They first came out with center pivots in the 1960s. It was all impact sprinklers right down the top of the spans on center pivots. Generally pivot pressures of 80 plus psi. Now we find that most pivot packages are running low pressure systems as low as 10 psi, but typically at the end of the system they need 25 psi to operate the types of spinners and rotators that they're putting out, or sprays that they're putting out on the end of those pivots. And so we only need pivot pressures of maybe a 35 or 40 psi. So we've cut the pressure in half, at least, on a lot of those systems. Well, that cut the pumping energy in half. If it took 100 horsepower to do it at 80 psi, to go to 40 psi, it only takes half of that horsepower. So we're down to 50 horsepower to do the same job, which would be pretty typical of a center pivot in this part of the world. So energy savings has become very eminent within the idea of what is right and what is good as far as operations are concerned. So we really are looking for systems that conserve water, conserve energy, and then the third little ringer in there is conserve the soil. You know, we can go and drop that energy way down and put great big water droplets out there, because that's what happens when you drop the pressure, is that the droplets get bigger and bigger and bigger. And all of a sudden a sprinkler nozzle starts looking like a little fire hose instead of a nozzle, instead of a sprinkler. The water's just going out in a stream and landing out there at the end of the pattern. Many of you have experienced that. When we have great big drops or a stream of water impacting the ground, you have the potential for erosion. If we can break that water up into itty-bitty little drops and let it just float to the ground, we minimize potential for erosion. We get maximum intake capability by really small drops. Of course, there's some major problems there too. We get all these little itty-bitty tiny drops falling, the wind, whoosh, blows them right sideways if there's any wind at all. If the sun's out, the radiant energy evaporates them right up into the sky. So we don't like little drops for those reasons, but we love it as far as the impact is concerned. We like big drops because we can throw a big drop out there quite a little way. Oh, those little drops, they don't go very far. There's a lot of air resistance as it tries to move through the air, and so that little drop's getting buffered by resistance. The bigger the drop, the more mass you have in it, the further it will project out. So as that big drop's projecting out, then it goes wham, just splat right in the ground, and you create a little problem with the soil surface. Now you're impacting the soil, you're creating an explosion where the droplet hits, driving the large particles down in the ground, the sand particles, the fines, the silts, and the clays get brought up to the surface because they're lighter, they float up, and if there's any gradient in the ground, that droplet isn't going to soak in instantly, so it wants to travel downhill if there's a gradient on the surface, if there's a slope. So all of a sudden you have the potential for erosion, surface runoff. So we really are fighting against surface runoff. And we get into some severe situations of surface runoff. You get up in the orchard country in the northern part of this state, some extremely steep ground. And so it is very, very critical to monitor the rate that we apply water on that steep ground.